All right, we're going to do one more thing with our geometric series, and we are going to do something called finding the sum of an infinite geometric series. Now, in your notes, it probably says something different right here, so I need you to scratch out whatever you need to scratch out to make this right. And also, you can scratch out anything in this box that doesn't look like what's in your box. There's some typos in it, something got copy and pasted wrong, but this is what it should say. Now, an infinite geometric series is one that goes on forever. So you might think, well, how can we find the sum of that? Because we can't add up everything if it goes on forever. But if you take a look at this example right here, so something you might be thinking is, well, we look at a series like this. It goes 2 times 2 is 4, times 2 is 8, times 2 is 16. And think, can we add that up? Well, no, we can't add that up because it'd be 2 plus 4 plus 8 plus 16. And then if we kept going, our numbers would just keep getting so big, so fast, that we'd never be able to add up and figure out what it finally stops at if it goes on forever. Now, if we just went from 2 to 16, we could add that up, but to add it up infinitely, we wouldn't be able to do. But some infinite geometric series we can add up. A quick example is one like this. This says the sum from 1 to infinity of 1 over 10 to the n minus 1. Now, we know that our a sub 1 in here, it's not written, but it's 1, right? So this is 1, so this is a sub 1 times r to the n minus 1, which is the form for our geometric sequences. So we're going to take this, our geometric series. So we're going to take this series and we're going to add up all the terms. So a sub 1 is 1 plus 1/10. And then if we did a sub 3, it's going to be 1 over 10 squared. So it's 1 over 100 plus 1 over 1,000. And you might be thinking, well, we can't add that up. But if we kept going with it and it just continued on forever, well, that's the same as 1 plus 0.1 plus 0.01 plus 0.001 plus, and it continues forever. Well, 1 plus 0.1 is 1.1, plus 0.01 is another 1, 0.001 is another 1, and that would just go on forever. So this sum right here equals 1.11 repeating, and we can find it. So we've figured out what that equals. A way that you can do it without writing out all the terms is by using this form for the sum of an infinite geometric series, and it's real easy. In fact, also cross out this n because we don't have an n. It's infinite. So the sum of an infinite geometric series is always going to be a sub 1 over 1 minus r, whatever the r is, and that's only if the absolute value of r is less than 1. And all that means r is a fraction less than 1. Okay? R is a fraction less than 1. That's kind of how you can think about it. So if r is less than or equal to negative 1, or r is greater than or equal to 1, then the series has no sum. Okay, that's all we're going to say. It just doesn't have a sum. We're not going to be able to do it. So take a look at a couple of examples here. We have the sum from 1 to infinity of 4 times 0.6 to the n minus 1. Well, our a sub 1 is 4, our r equals 0.6, and our n equals, well, we're going to do an infinite sum, so we're going to write s equals a sub 1 over 1 minus r. So our sum is going to equal 4 over 1 minus 0.6. So 4 over 1 minus 0.6 equals 10. And that may not make a lot of sense to you, but our pattern here goes a sub 1 is 4. Then we're going to add a sub 2. So we put a 2 here. It's 2 minus 1, which is 1, 2.4. Then we do a sub 3. So we're going to put a 3 in here. 3 minus 1 is 2, is 1.44. If we keep going with that, you can see that our numbers here are getting much smaller, smaller and smaller very fast. So if we went on forever and it just continued for infinity, it would all add up to 10. And so that may be a difficult concept to think about right now, but just focus on the formula, okay? Focus on getting this right. So here we go. A sub 1 equals 6, r equals 1.6, and n equals infinity. And we want to do our formula, a sub 1 over 1 minus r. But our r is 1.6, which is not less than 1. So we're going to say that this has no sum or no solution. Okay, that's all there is to it. If the r is bigger than 1, meaning it's some kind of fraction, or it's not some kind of small fraction, sorry, then no solution. So find the sum of the infinite geometric series. So a sub 1 equals 9. R, our common ratio, is what do we have to do to 9 to get 6? Well, we multiply it by 2/3, multiply by 2/3, so that's our common ratio. And normally we would need to find our n, right? Because we don't know how many things are in the series, but we do know because it's an infinite geometric series. So S equals a sub 1 over 1 minus r. S equals a sub 1 over 1 minus r. So 9 over 1 minus 2/3, you do it in your calculator, it's 27. And that's it. Have a great night. That is the last video before our test.